Welcome back to Talk Tensors. Are you ready to dive deep into the world of avatars?
Always ready for a deep dive, especially one that promises to revolutionize how we create and interact with digital humans.
That's exactly what we're doing today. Buckle up, because we're taking a close look at Gaussian Eigen Models for human heads. This paper has the whole AI community buzzing.
Rightfully so. It proposes such an elegant solution to creating personalized and realistic avatars, but without all the typical computational headaches.
Okay, I gotta admit, you've got my attention now. I mean, the idea of rendering lifelike avatars, but on, say, a mobile phone, that's pretty mind-blowing.
It really is. And the secret sauce behind this is, well, they call it Gaussian Eigen Models, or GMs for short.
Right, GMs, I'm all ears. What exactly makes them so special?
So imagine you're building something with Legos, but instead of using thousands of individual bricks, you have these pre-designed components, each one capturing the essence of, well, various facial features.
Okay, I'm following. So instead of modeling every single detail of a face, we're working with these kind of prefabricated facial feature blocks.
Exactly. And these components, they're derived by analyzing what are called 3D Gaussian primitives.
Gaussian primitives.
Yeah. Think of them like little mathematical blobs that represent a person's face.
So we're building faces out of blobs now. That's pretty cool. But how do we even create these blobs in the first place?
Good question. It's a multi-step process. They start with a super detailed model trained on tons and tons of video data. It's computationally intensive, but it captures like every tiny nuance of a person's facial expressions.
Okay, so this is like having a master sculptor meticulously chiseling away at a block of digital clay.
Perfect analogy. But now we need to turn that master sculpture into a set of those Lego-like building blocks we talked about, right?
Right. So how do we go from this incredibly detailed sculpture to, well, something more manageable?
And that's where the real magic happens. Through a bunch of mathematical transformations, the essence of this complex model, it gets distilled into a set of what are called eigenbases.
Eigenbases?
Yeah, eigenbases. Think of them as the blueprints for our facial feature blocks. And by cleverly combining these blueprints, GMs can generate just this vast range of realistic expressions, but so efficiently.
Wow, it's like having a recipe for a face. You can tweak the ingredients to create like an infinite variety of expressions. That's amazing. You know, this whole eigenbase thing, it makes me think it's got some serious history in computer graphics, right?
Absolutely. Eigenbases, or sometimes they're called eigenvectors, they've been around for a while. Like they've got applications in physics, finance, you name it. It's essentially a way to break down complex systems into like their fundamental building blocks.
So how did researchers go from using them for things like physics to applying them to, well, something like facial modeling?
Well, if you think about it, early facial modeling was pretty basic, like simple geometric shapes or those parameterized models. They lacked the realism and flexibility for anything, well, sophisticated.
Right. I remember those early avatars. Pretty clunky and robotic.
Exactly. And then blend shapes came along. This involved creating a ton of models for different expressions and like blending between them.
So that was a step up in realism.
Oh, indefinitely. But it meant creating and storing a massive amount of models. Computationally, it was expensive and just, well, hard to manage.
So the challenge was to find a way to capture all the complexity of facial expressions, but without drowning in all that data.
You got it. And that's what led to those data-driven approaches. Using statistical methods to analyze huge data sets of facial scans, motion capture data, all that.
And that's where eigenbases really started to shine, right?
Precisely. Researchers realized you could use eigenbases to capture the underlying structure of facial variation, meaning they could represent this huge range of expressions with a relatively small set of parameters.
So it's like they found the hidden code that controls how our faces move.
In a way, yeah. And all of this leads up to the development of, well, GMs.
So GMs are like the culmination of all this research into facial modeling and these data-driven approaches.
Exactly. They build on all that using eigenbases derived from those, remember those Gaussian primitives?
The blobs.
Yes, the blobs. It creates this incredibly compact and efficient representation of expressions.
This is amazing. But what makes GEMs stand out from all the other techniques, especially the ones that also use eigenbases?
One of the key innovations, and it's a big one, is the use of what are called deformation gradients. They're these mathematical tools that allow GEMs to accurately capture like the unique shape of an individual's face, like those subtle variations that make us all, well, us.
So it's not just about creating a realistic face, it's about creating avatars that are truly personalized, right? Reflecting each person's unique facial structure.
Exactly. And that personalization is crucial for creating avatars that feel authentic and believable.
It's like taking a generic face model and like custom fitting it to your unique features.
Yeah.
Every detail. That's pretty impressive. You also mentioned earlier that gems are super efficient. So how does that actually play out?
Well, traditional avatar models, they need a ton of data and processing power, makes them pretty impractical for devices with limited resources. But gems, they're incredibly lightweight. They need a fraction of the data and processing power.
So we're talking about the possibility of real-time animation, but on like a smartphone, not just a powerful computer.
Exactly. This efficiency opens up a whole world of possibilities, especially for anything real time. And speaking of that, the paper shows how gems can be animated in real time from just single RGB images. They use a regressor network.
Hold on, you're telling me I could control my avatar like in real time using my webcam?
That's the idea.
That's incredible. What else can these gems do?
Well, they also explored what they call cross-person reenactment. It's the ability to transfer expressions from one person to another person's avatar.
Wait, so you're saying I could take my facial expressions and put them onto your avatar, and it would look realistic?
Yeah. And the results are surprisingly good. They even compared gems to other state-of-the-art methods like Gaussian avatars and animatable Gaussians. Gems consistently performed better in terms of quality and their ability to generalize to new expressions.
This is all very impressive, but before we get too carried away, I want to make sure we're all clear on some of the the technical nitty-gritty. You mentioned UV space normalization earlier. Can you explain what that is and why it's important?
Of course. So UV space normalization, it's a technique to make sure those 3D Gaussian primitives, remember those little blobs?
Yeah.
They need to be mapped consistently across all the different frames and expressions. Imagine you're tracking, say, a freckle on your cheek as you smile. If the mapping system is off, that freckle could jump around. You wouldn't get a smooth, realistic animation.
So it's about making sure those blobs are always in the right spot, no matter how the face moves.
Exactly. UV space normalization keeps everything stable. Makes sure those Gaussian primitives are mapped in a consistent way, like creating a coordinate system for the face that stays accurate, even when the features are moving.
So it's like a roadmap for those blobs, making sure they don't get lost.
That's a great way to put it.
Yeah.
Okay, I think we've covered the main technical stuff and, well, laid a good foundation for understanding what makes gems so significant. But now it's time for my favorite part of the show.
Novel discussions.
Yes. Or we take these amazing ideas and, well, see just how far we can push them.
Exactly. So the paper focuses on creating personalized gems for each individual face. But what if, and hear me out here, what if we could create a universal gem?
A universal gem. Now, that's an interesting thought. You're talking about one model that could capture, like, the commonalities across all human expression.
Exactly. Instead of needing separate gems for each person, we could have this one master gem that could generate any face and any expression.
Whoa, that's a pretty bold idea. It would be a massive undertaking, but think of what we could do. We could streamline the whole process of avatar creation, make it even more accessible, more efficient.
It'd be like having a single blueprint that could create any human face you can imagine. The ultimate Lego set for faces.
It would certainly push the limits of facial modeling. We'd need a much deeper understanding of how human expressions work. What are those core components of facial movement that are shared by everyone, regardless of their unique features?
We'd be cracking the code of human expression. Imagine creating avatars for historical figures, fictional characters, even completely new, imagined beings.
The possibilities are really endless, but we've got to be realistic. There would be some serious hurdles to overcome.
Like what?
Well, we'd need a huge data set of expressions, all ages, ethnicities, different facial structures. We'd have to capture the subtle variations that make each face unique, but also figure out what they all have in common.
It's like searching for the universal language of faces.
Exactly. And on the technical side, we'd need to come up with new algorithms, new techniques that could pull out and represent these universal components of facial movement.
So it's not just about getting more data, it's about figuring out how to actually analyze and understand it in a whole new way.
Exactly. We'd need some seriously sophisticated machine learning models, ones that can find those subtle patterns and relationships in a sea of data. It's like teaching a computer to not just recognize faces, but to truly understand what human expression is all about.
That's incredibly ambitious, but it's exciting to think about. What if we could really unlock the secrets of human expression? I mean, even if a universal GM is a long way off, the work being done with personalized gems is already pushing the boundaries of avatar technology.
It really is. And it's clear that Gaussian Eigen Models have opened up all these new possibilities for digital human representation. It's a pretty exciting time to be following all of this. It is. It really is. And it's amazing to think about how much has already been accomplished. Just to recap, we started by looking at the core concept behind these Gaussian Eigen Models, GEs. Remember, they provide this really revolutionary approach to creating personalized, realistic avatars. And they do this by representing facial features as a combination of, well, those 3D Gaussian primitives, those little blobs.
Yeah, the blobs that capture the shape of the face.
Right, but it's not just randomly placed blobs, is it? They're organized and controlled by a set of eigenbases, like blueprints for different facial features.
And if I remember correctly, those eigenbases are actually derived from a really complex model, right? One that's been trained on tons of facial data.
That's right. And through a series of mathematical transformations, the core of this complex model is distilled into those compact eigenbases.
It's like taking this huge encyclopedia of facial expressions and boiling it down to a pocket dictionary.
I like that, a perfect analogy. And it's that efficient representation that makes gems so groundbreaking. They require way less data and processing power compared to those traditional avatar models, which really opens up a world of possibilities for, well, real-time applications, even on devices with limited resources.
It's like we're talking about rendering those photorealistic avatars on your phone, not just a high-end gaming computer. All this efficiency is impressive. But what about the realism? How do gems ensure that these avatars actually look like real people?
Ah, that's where the clever use of those deformation gradients comes in. It's like taking a generic face model and molding it perfectly to your features, capturing every little detail from the curve of your cheekbones to the shape of your jawline.
So we're not just creating realistic faces, we're creating avatars that are truly personalized, reflecting the individual's unique facial structure.
Exactly. That level of personalization is what sets GMs apart. They're not just creating generic avatars, they're creating digital representations that capture those little nuances that make each person's face unique.
It really is groundbreaking. It feels like we're moving into this new era of digital human representation, where avatars aren't just crude approximations, but these incredibly realistic and personalized reflections of ourselves.
I agree. And that level of realism, well, it has big implications for a ton of fields. Entertainment, gaming, virtual communication, even healthcare.
And speaking of applications, the paper itself highlights some really exciting possibilities, like real-time animation just using a webcam, that cross-person reenactment where you can transfer your expressions onto someone else's avatar.
Yeah.
Even the compression capabilities are really impressive. It makes these models so compact, so manageable.
It's amazing what they've achieved. And the exciting part is they've only just scratched the surface. There's so much more potential to explore.
My mind is already spinning with possibilities. But before we dive into all that, I want to go back to something you mentioned earlier, that UV space normalization. Can you break that down for us, like in a way that even someone who's not a computer graphics expert can understand?
Sure. So those 3D Gaussian primitives, those blobs that represent the face, they need to be mapped in a consistent way across all those different frames and expressions. Imagine you're trying to track the movement of, say, a freckle on your cheek as you smile. If the mapping system isn't consistent, that freckle might jump around. It wouldn't be a smooth, realistic animation.
So it's about making sure all those facial blobs stay like anchored to the correct points on the face, no matter how the face is moving or changing expression.
Exactly. UV space normalization, it provides that stability. Make sure those Gaussian primitives are mapped consistently, like creating a coordinate system for the face, one that stays accurate, even when everything is moving around.
It's like we're creating a roadmap for those facial blobs, right? To make sure they don't get lost.
I love it. A roadmap for the blogs. That's a great way to think about it. I think we've covered those key technical details and laid a good foundation for understanding what makes GM so important. But now it's time for my favorite part of the show.
You mean novel notions?
Novel notions it is. Time to take all these amazing ideas and, well, push the boundaries, see how far we can go.
Okay, so the paper focuses on these personalized gems for each face.
Right.
What if, hear me out, what if we could create a universal gem?
A universal gem. You're talking about a single model that could capture all those commonalities we see in human expressions.
Exactly. Instead of creating individual gems for each person, we could have this master gem. It could generate any face, any expression.
That's certainly a bold idea. It would be incredibly challenging, but the possibilities, we could completely change the way we create avatars, make it much more accessible, much more efficient.
Like having a single blueprint. But it can generate any human face you could possibly imagine. The ultimate facial Lego set.
Now that's an image. It would completely push the limits of facial modeling. We'd need a way deeper understanding of those underlying principles that govern human expression. Like, what are those core components of facial movement that are shared across all people, regardless of their unique features?
We'd be like cracking the code of human expression. Imagine if we could create avatars for historical figures, for fictional characters, even completely new beings.
Endless possibilities. But let's not get ahead of ourselves. There'd be some major hurdles to overcome.
Like what?
Well, first off, we'd need an enormous data set of facial expressions. All ages, ethnicities, different facial structures. We'd need to capture all those subtle variations that make each face unique, but also figure out what makes them similar.
We'd be searching for the universal language of faces.
That's a great way to put it. And on top of that, on the more technical side, we'd need to develop some brand new algorithms, new techniques that could extract and represent these universal components of facial movement.
So it's not even just about collecting more data. It's about coming up with totally new ways to analyze it and understand it.
Exactly. We'd need really sophisticated machine learning models, ones that can find those subtle patterns and relationships in all that data. Like, we'd be teaching a computer to not just recognize a face, but to truly understand human expression.
That's a pretty ambitious goal.
Yeah.
But what a payoff to truly unlock the secrets of human expression. Even if that universal GM remains a distant dream for now, the work that's being done with these personalized gems is, well, it's already incredible, pushing the boundaries of what's possible in the avatar world.
It really is. I completely agree. The innovations in this paper, they're significant, and I have no doubt they're going to have a big impact on how we interact with, well, and represent ourselves in the digital world.
It's clear that these Gaussian Eigen Models have opened up a whole new world of possibilities for digital human representation. And it's such an exciting time to be following all of this. It really is. And, even without that universal gem, the possibilities for these personalized gems are still pretty amazing. We've talked about entertainment, gaming, but what about other industries?
Oh, the potential is huge. Think about medical students practicing surgeries, but on super realistic virtual patients, with avatars that could, like, mirror subtle muscle movements, even reactions. Or architects presenting designs with lifelike avatars that can walk through the space, showing how a building will actually feel.
We could have virtual therapists providing support, but with avatars that are so expressive, it can make the whole experience more personal, more engaging. Or how about personalized online shopping with virtual fashion models that, well, actually look like us?
Exactly. And let's not forget about accessibility. Imagine avatars that could translate sign language or provide real-time captioning. We could create digital environments that are more inclusive for everyone.
It's amazing to think how these gems could really empower people in so many different fields. It's a good reminder that technological innovation, it's not just about those cool gadgets. It's about using these tools to solve real-world problems, to make a positive impact.
I couldn't agree more. And the thing about gems is they're not just limited to visual representation. I mean, a paper focuses on faces, but the underlying principles, you could apply those to other parts of the body, even entire characters.
So instead of just realistic faces, we could have full-body avatars, ones that move and interact with the world in these incredibly lifelike ways.
Precisely. Imagine, like, a virtual athlete training for the Olympics. Their avatar could respond to the physical exertion, show realistic muscle fatigue, even sweat. Or a dancer, perfecting their routine. Their avatar could capture every nuance of their movement.
This is starting to sound like science fiction.
I know. But with how fast things are moving in machine learning and computer graphics, well, maybe it's not so far-fetched.
Maybe not. And as this technology keeps developing, we can expect even more creative and, well, transformative applications to come out of it. This is really just the beginning.
It is just the beginning.
This deep dive into Gaussian Eigen Models has definitely left me feeling inspired. It's amazing to see how research is pushing the boundaries of, well, everything we thought was possible with digital human representation.
It really is a testament to human ingenuity. All those endless possibilities that come from combining creativity with cutting-edge technology.
Who knows, maybe someday we will crack the code for that. that universal GM, and unlock even more possibilities for digital avatars. But for now, I want to thank all of our listeners for joining us on this incredible journey into the world of gems.
It's been a pleasure.
And if you're as fascinated about gems as we are, be sure to check out the paper. We've got the link for you in the show notes. And if you have any novel notions of your own, we want to hear them. Leave us a comment or join the conversation on our social media. Until next time, keep those imaginations firing and those avatars evolving.